So for our next talk we have Mike Paetz from Redox to talk about mapping HL7v2 events to FHIR.
All right, so I'm Mike. I'm a software engineer at Redox. And probably helpful for this talk is a little background as to what Redox does. So Redox, we're all about making healthcare interoperability easier. And one of the primary ways that we do that is facilitating real-time bidirectional data exchange of healthcare data. And one of our big brand promises is that you can code up once and connect everywhere. So we present a single unified API on one side to our customers, and then that can connect to any sort of data source on the other end, whether that's X12, HL7v2, FHIR, XML, CDA, various custom APIs, anything like that. So historically, we've done that with a proprietary API that we've developed, but this is 2024, and we would really like to use FHIR, and all of our customers would like to consume FHIR. So we'd like to get rid of that piece over there where we have Redox Data Model API. So a couple of considerations in doing that. So the obvious choice of doing having like RESTful FHIR server interactions is a bit challenging in our model because we're not really interested in being a FHIR server. We don't want to be a repository for our customers' data. We want to be a transit mechanism. And we don't want to store that beyond what we need to for translation and transit. And so that choice is not really open to us. And so thinking about some of the other options that are provided for FHIR, we ended up selecting FHIR Messaging. And so the way that we implement our new API, our FHIR API, is through a combination of FHIR notifications and then FHIR writebacks for data flowing back into our network. And both of those are actually implemented using the same paradigm. We're using FHIR bundles, and in particular, we're using the message bundle. This lets us one of the other challenges here is thinking about where is the data coming from. For something where it's coming from FHIR or even perhaps some of these proprietary APIs, that is available from a RESTful endpoint, and so it could be queryable. But some of these other formats aren't. HL7v2, those are all going to be push events, and so are some of the other formats that we encounter. And so in order to maintain that brand promise of code up once and you can send your data everywhere or receive data from everywhere, we have to have something that works for all of these different formats. And so for us, that's how we came about choosing FHIR bundles. So digging in a little bit to what does a FHIR bundle look like? So we have a bundle resource that's of type message. The first entry resource there is a message header resource, and this is where we can have some of that metadata about what the source system was that this was coming from, and so we keep track of the actual sender separate from the actual source application that sent it, because in our case those can be two different things, since we have the customer sending it on the left, and then the actual source they connected to Redox through, we can maintain both of those with the message header. We pass through the trigger event that caused this. So for HL7v2, that would be where a message type and event type would go. And then we translate that we map that to a custom-defined Redox event. And so this is where we're providing a standard interface across all of these diverse data formats. And then finally, the message header defines the focus resource for the message. So this is perhaps what the message was referring to. So in the example of something like a patient admit message, this would probably refer to the patient. And something like a ORM, that would refer to the service request. And then the bundle can contain other resources. And so then all the other FHIR resources are a part of that. So we have two directions here. So we can talk about notifications first. So this is outbound from our network. And we provide a couple of flavors here. Thinking back to like there's those couple different types of data sources, we have two flavors of notifications. Lightweight, where we really just provide the IDs for what happened. We don't provide full payloads. This is great if the source on the other end is queryable for the rest of that information. So if it's something like, if it's from a FHIR source, for example, or if it's from a queryable API, Athena Health, something like that, this is a great choice. But that doesn't really work for the sources that we can't query. And so for those, we provide a detailed notification that includes full resources in the payload, everything you could possibly want to know about the event that happened. And then in that case, the client doesn't need to make any further queries to receive their data. Looking at the return path, we have similar considerations in that the customer doesn't necessarily know where they're sending it to on the other side. We could be sending it to these diverse sources. And we have to kind of think about, in choosing how to do this, think about a least common denominator principle. So what does the message have to look like, and how much information does it have to contain such that we could send it to any of these different systems? And so that is why we go with message bundle again for this. So in some cases, this will be, it's a bit of overkill. And in other cases, like this is how we can get the information. So once this flows into our system, that message then can take a number of different paths. For HL7v2, it's probably translated in full to a single message and transmitted to the destination system. If the destination is a FHIR server, for example, we probably split that up into multiple requests and write the resources individually. And then the way that we actually implemented Writeback was creating a series of custom dollar operation endpoints. And there's an example of that here for a service request. And these map directly to the custom Redox events that we've defined. And then those can be translated then through mappings in our engine to customer systems. That's most of what I wanted to cover. So if you want to see more examples of this, they are up on our docs website. Otherwise, anybody have any questions?
One question I had is when you're sending those bundles across, have you run into any issues with performance in terms of the size of the bundle? In case in point, if you have a CCD that has a longitudinal record on there or something like that?
Yeah, that's a good question. So we do have resource limits in place. In practice, that hasn't been a huge issue. With even with larger resources like CDAs or converted CDAs.
Any other questions? Okay, well, thank you.
Thanks, everybody.